Okay, Wildcats, today we're looking at Friday, January 25th, square root transformations on page 45. If you would, update your table of contents. All right, now your table of contents are updated. Let's take a look at the notes. All right, square root transformations on page 45. So we have f of x equals negative a square root of negative bx minus h plus k, where the negative in front of the a reflects over the x-axis. When a is greater than 1, it's a vertical stretch. When a is greater than 0 but less than 1, it's a vertical compression. When the negative in front of b, it reflects over the y-axis. When b is greater than 0 but less than 1, it's a horizontal stretch. When b is greater than 1, it's a horizontal compression. When it's plus h, it translates left. When it's minus h, it translates right. When it's plus k, it translates up. When it's minus k, it translates down. You would finish up your notes. All right, now your notes are updated. Let's look at our examples. All right, it says graph the square root function, describe the transformation, and state the domain and range. So in example 1, we're going to start out with the square root parent function. Okay, so that's the parent function. Okay, so now let's graph. So we're going to make a table. Now, with square roots, the smallest number you can start with is 0 because you can't take the square root of a negative number. So let's let x equal 0. So the square root of 0 equals 0. So our first point is 0, 0. Now we look at 1. And the square root of 1 is 1. So our point is 1, 1. Now, we're not going to do 2 as our point because the square root of 2 becomes a decimal. Square root of 3 is a decimal. But the square root of 4 we can use because the square root of 4 is 2. So we go to the right. 1, 2, 3, 4, up 2. And then we're going to go on to the next point is 9 because we know the square root of 9 is 3. So we go to the right 9 up 1, 2, 3. Now you could technically use the other points, but graphing decimals makes it more complicated to graph, so we want to keep the simple numbers. Okay, so there's your square root parent function. Okay. Now there's no transformation because it's the parent function. The domain is bracket 0 to infinity, and the range is bracket 0 to infinity. All right, example 2. Now we're going to graph by direction. Okay, so we know our vertex h and k is what we're going to do the initial transformation move. So we look, this minus 1 means the vertex moves to the right 1 and up 2. So from here we go to the right 1, up 2. There's our new vertex. Okay. Now our direction we can base on our parent function. So we know directions are 1, 4, 9, 1, 2, 3. But we have to multiply the y direction by negative 3. So that's negative 3, negative 6, and negative 9. So from here we go to the right 1, down 1, 2, 3. To the right 4, to the right 1, 2, 3, 4, down 1, 2, 3, 4, 5, 6. and to the right 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9, down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so there is our transformation. All right, so now we list the transformations. Now I count 1, 2, 3, 4 transformations, and that's the order of which we're going to write them. Okay, so the first one is with a negative, so that reflects the x-axis. Okay, the next one, the 3, is a vertical stretch of 3. The next one, that is, it's to the right 1. And the last one is up 2 units. All right, now domain is bracket. In this case, it was shifted to the right 1, so it's 1 to infinity. Now, because it's reflected, we're actually in the range, we're actually coming from negative infinity to bracket 2. All right, if you would finish up example 1 and 2. All right, now let's take a look at the next examples. Use the description to write the square root function g based on the parent function f of x equals the square root of x. Example 3. F is reflected over the x-axis, compressed vertically by a factor of 1/5 and translated down 4 units. So f of x equals, now reflected across the x-axis, so that means the negatives in front. Now compressed means the 1/5 is in front of the square root, and then the down 4 is a subtract 4. All right, let's take a look at example 4. Reflect f across the y-axis and translate 3 units up. So that's f of x equals the square root. Now, when it reflects over the y-axis, the negative is on the inside of the square root, and up is a plus 3. Example 5. F is translated left 5 units and 4 units down. So that's f of x equals 5 units left. So it's opposite of what you think. So it's x plus 5, and then down is minus 4. All right, let's take a look at example 6 and 7. Graph the square root inequality using transformations. Okay, so we're going to graph by direction. So now we move the vertex. So that plus 4 means we go left 4. So 1, 2, 3, 4. Now we know that's our new h and k. And we know from the parent function we have 1, 1, 4, 2, 9, 3. So we go to the right 1, up 1. To the right 4, 1, 2, 3, 4. 1, 2, 3, 4, up 2. And then 5, 6, 7, 8, 9, up 1, 2, 3. Now, because we're graphing inequality, there's no line needed, so it's a dashed line. Okay. Now, we know because of square root, you can't have anything less than negative 4, because negative 4 plus 4 is 0. This value would be a negative square root at negative 5. So we're going to draw a vertical line here, meaning that we can't shade anything past that. It's greater than, so we shade above. All right, now let's take a look at example 7. So first thing first is we move the vertex. So we're here. and we go up 3. 1, 2, 3. Now we graph by direction. I'm going to go and lose this shading here so I have space for the table. So we now have our new vertex, which is here, and we know our directions from the parent function are 1, 1, 4, 2, 9, 3, but we have to multiply the y values by a negative 1. So that's negative 1, negative 2, negative 3. So we go to the right 1, down 1, to the right 1, 2, 3, 4, down 2, and to the right 5, 6, 7, 8, 9, down 1, 2, 3. There's a line underneath, so it's a solid line. We know that we can't go to the left of 0 because a negative under the square root won't work. So we draw a vertical line here. And then we know it's less than, so we shade below. All right. So there you go. If you would, finish up your example, start working on your assignment, and have a wonderful Wildcat day.